Welcome to Lecture 3 in the series of lectures on functions of a real variable. The title of our lecture is Domain and Range of a Function. I am your lecturer, Professor E.O. Efanga. The domain and range of a function. Given the function f from a to b, the set A is called the domain of f, while the set B is called the codomain of f. The set of all images of the element of A under f is called the range of f. We know that the range of f is a subset of the codomain. Given the function in an expression form y equal to f of x, the domain of f is the set of all values of x for which the function f of x is defined or finite, and the range is the set of all values of y for which y is equal to f of x. Thus, the range is the set of all values of y for which the inverse of f of x is defined. That is, for which x is equal to g of y, which is equal to f inverse of y, is defined. Example number 1. Consider the function f from a to b, in which A is a set of elements a, b, and c, and b is a set of elements 1, 2 to 9. And the function f is defined as follows: f equal to the set of ordered pairs a1, b3, c2. Then the domain of f is the set A of element a, b, c. The codomain of f is the set B of element 1, 2 to 9. And the range of f is the set of all images of element of A under f. That is the set of element 1, 3, and 2. Example 2. Consider the function f of x equal to x squared plus 1. Then, for any real number x, this function f is defined. That is, given any real number x, we can always find the value of x squared plus 1. So, the domain of f is equal to the set of all real numbers R. To find the range of f, we set y equal to x squared plus 1 and then make x the subject of formula. That is, x is equal to plus or minus the square root of y minus 1. This is a function of y. For any real number y which is greater than or equals to 1, this function g is defined. Thus, we can only find the square root of a non-negative number. That is, if y minus 1 is greater than or equal to 0, that means y is greater than or equals to 1. So therefore, the range of f is the set of all y such that y is greater than or equals to 1 and y is element of R. That's the set of all real numbers greater than or equal to 1. Example 3. Consider the function f of x equals to 1 all over x minus 3. Then, this function f is not defined at x equals to 3, because when x equals to 3, you have 1 over 0, which is not defined. So therefore, the domain of f is the set of all x such that x is not equal to 3 and x is element of R. That's the set of all real numbers except 3. To find the range, we set y equals to 1 all over x minus 3, and then make x the subject of formula. That is, x is equal to 3y plus 1 all over y, and this is a function of y. This function g of y is not defined at y equal to 0, because 3y plus 1 all over 0, when you divide a number by 0, is undefined. So therefore, the range of our function f is the set of all y such that y is not equal to 0 and y is a real number. That is the set of all real numbers except 0. Example 4. Consider the function f of x equal to the square root of x minus 2. Then f of x is defined for all x greater than or equal to 2. Thus, we can only find the square root of a non-negative number. When x minus 2 is greater than or equals to 0, that means x is greater than or equals to 2. So therefore, the domain of f is the set of all x such that x is greater than or equals to 2 and x is element of R. That's the set of all real numbers greater than or equal to 2 is the domain of f. To find the range, we set y equal to the square root of x minus 2. Squaring both sides and making x the subject, we have x equal to y squared plus 2. This is a function of y. This function is defined for all real values of y. For any real number y squared plus 2 can always be determined. But y equal to the square root of x minus 2 implies that y is a non-negative number. So therefore, the range of our f is the set of all y such that y is greater than or equals to 0 and y is element of R. That is, the range of f is the set of all real numbers greater than or equal to 0. Example 5. Let f be a function from a to b defined by f of x equal to the square root of x plus 1. Then f is defined for any non-negative real number x. When x is non-negative, we can find the square root of x and then plus 1. So therefore, the domain of f is the set of all x such that x is greater than or equal to 0 and x is element of R. Thus, the domain of f is the set of all real numbers greater than or equal to 0. To find the range, we set y equal to square root of x plus 1. Taking 1 to the left hand side, that will give us square root of x equal to y minus 1, and squaring both sides, we obtain x equal to y minus 1 all squared, and this is a function of y. This function g of y is defined for all real number y. For any real number y minus 1 all squared can be determined. So therefore, the range of our function f is the set of all real numbers R. Example 6. Find the domain and range of the function f of x equal to 1 minus x all over 1 plus x. Solution. The function f is undefined for x equal to minus 1. Observe that when x is equal to minus 1, you have 1 minus 1, 0. So 1 minus 1 will be 2 all over 0. So that function is not defined at x equals to minus 1. So therefore, the domain of our function f is equal to the set of all x such that x is not equal to minus 1 and x is element of R. That's the set of all real numbers except minus 1. To find the range, we set y equals to 1 minus x all over 1 plus x. Upon cross multiplication, we will obtain y plus xy is equal to 1 minus x. Then bringing terms in x together, This will give us x into 1 plus y is equal to 1 minus y. Dividing both sides by 1 plus y, we have x equal to 1 minus y all over 1 plus y. And this is a function of y. This function is not defined at y equals to minus 1. So therefore, the range of our function f is the set of all y such that y is not equal to minus 1 and y is a real number. That's the range of our function f is the set of all real numbers except minus 1. On your own, find the domain and the range of each of the following functions. 1. F of x equal to 5x squared minus 3x plus 2. 2. F of x equal to 1 all over 2x plus 1 times x minus 3. 3. F of x is equal to the square root of x plus 1. 4. F of x is equal to 1 all over square root of 3x minus 6. We have come to the end of our lecture. Thank you for watching and keep on watching.